So if I asked you to solve 1 minus 2 times the cosine of x equals 0, if this was just plain 1 minus 2x equals 0, what's the first thing you would do? Bring the 1 to the other side. So nothing is changing just because we have trig functions. So when we take that 1 to the other side, goodness bless you, we'll have negative 2 times the cosine of x is equal to a negative 1. And then what would we do? Divide by negative 2 to get the cosine by itself, right? So cosine of x is now positive 1/2 because negative divided by negative is a positive. Okay, so we're not quite done because we want to figure out what's the value of x that makes the cosine a positive 1/2. We would do inverse cosine if it wasn't one of these that we should know off the top of our head, right? So where's the cosine 1/2? Pi over, not pi over 6, pi over 3. It's a 60-degree angle. Cosine is 1/2 at a 60-degree angle, okay? Not just at pi over 3, but where else is cosine a positive 1/2? Pi over 3, 2 pi over 3, 3 pi over 3, 4 pi over 3, 5 pi over 3, right? Okay, and also at 5 pi over 3. So pi over 3 is one of our answers. 5 pi over 3 is another answer. And they didn't restrict us. They didn't say your domain is only between 0 and 2 pi. So we would have to say plus any 2 pi increments. You can keep going. Every 2 pi, pi over 3 plus 2 pi more, plus 2 pi more, plus 2 pi more, 5 pi over 3 plus 2 pi times any integer will get us an answer where cosine is 1/2. I'm sorry. N is just an integer, just a counting number. Yep. We need to have both answers. Yep. Both possibilities where cosine is positive 1/2. Okay. Now, I gave you a unit circle on the back of your trig identities because that can help you. Okay. You can ask yourself, where was the cosine 1/2? That's the x or y value of the ordered pair. Cosine is the x, okay? So you can look here to see, oh, guess what? There's my positive 1/2 at pi over 3. Okay, back to our unit circle. And where else was it positive 1/2? Over here at 5 pi over 3. Okay, so back to using that reference unit circle. Make sense? Haven't lost anybody. So we're reiterating and reviewing some of the stuff we learned last chapter. Okay, next one. Sine of x plus 1 is equal to a negative sine of x. How would we solve that? You can add the other sign to both sides. So I will have 2 of these sines of x. And I'd have a 0 over here. But let's get rid of this 1. Okay. Now, what do I have to do to get the sine of x by itself? Divide by 2. So now the sine of x is negative 1/2. And we want to know what value of x makes the sine a negative 1/2. Okay. So where was the sine 1/2 at? Pi over 6, a 30-degree angle. But it needs to be negative now. Quadrants 2, 3, and 4, correct? So where is the sine negative 1/2? The y value is negative 1/2. 7 pi over 6 and 11 pi over 6. Because sine is the y of the ordered pair. and then any other rotations, right? So plus 2 pi times any integer. Okay. 2 pi later, it'll also be a negative 1/2. Another 2 pi after that will be a negative 1/2. A couple 2 pi's backwards would get us a negative 1/2. Okay. So unless they restrict our domain, we have to add this 2 pi n to the end. Okay. What if we say tangent squared of x minus 3 equals 0? Add the 3. Absolutely. So where is the tangent of x equal to a plus or minus square root of 3? We have to be careful on that one. Anytime we square root, we can't forget that we have to take the positive or the negative. That will get us that value. So where is tangent square root of 3? Pi, tangent to square root of 3 at 60 degrees, right? So pi over 6, okay? So we want every pi over 6. So we're going to have the tangent here. That's a positive square root of 3. That would be one of the negative square roots of 3. That would be the other positive square root of 3. And this would be our other negative square root of 3. Okay? So you can list all 4 of them out, but won't pi over 6 plus any multiple of pi get us this guy? Okay? And wouldn't 5 pi over 6 plus any multiple of pi get us this one? Okay, so you can list all 4 plus the 2 pi's, but we can reduce that and simply say pi over 6 plus pi times n, or that's our positive, here's our negative, 5 pi over 6 plus a pi times n. And that covers it, yes. It is, a tangent is always a 60-degree angle, and I did that wrong. I wrote down the 30s. Thank you. Thank you for catching that. Because square root of 3 over 3 are our 30s. I wrote those wrong. Said 60 and did the opposite. So we want the 60-degree angles. The pi's over 3's. Okay, so we want a pi over 3 plus pi n. This thing takes it as a marker. Okay, so pi over 3 plus a pi n, and then we wanted 2 pi over 3 plus a pi n. And you wouldn't be technically wrong if you also said 4 pi over 3 plus pi n and 5 pi over 3 plus pi n, but that's a whole lot of writing, 2 pi n, because we can simplify it since we're wanting all 4. Okay, because our original equation, or our original expression, didn't say only tell me between a certain range of values. Okay, so they didn't say I want you to restrict this between 0 and pi over 2 or 2 pi. Okay, so because they didn't restrict our domain, we have to realize that we can go 60 degrees and get this value. Also the 120 degrees, 240, and 300. But then we can also go back here to 360 plus 60, or 420, and keep going, right? There's multiple places we can keep going on and on and on and on and on and on and on, and still get those same values. Just some integer. Yep. Yep. So we can take it, we can add a single pi or 2 pi or 3 pi or 4 pi or 5 pi, and we'll still get to those places on the unit circle where those values are going to be the same. Okay? Does that make sense to everybody? Okay. So we did not restrict our domain to say only in one unit circle. Can keep going, keep revolving. Okay, Okay, give me a couple. I have, I think, one or two more. Okay. So this looks messy. And we don't want to just divide by cosecant of x, because that could potentially eliminate answers. Okay? It's the common thing that everybody wants to do, is just divide it out and just talk about secant. So let's bring everybody to one side. Everybody go okay with that? Now, what do both terms have in common? A cosecant. So if I factor that cosecant of x out, it's like dividing this by cosecant of x and dividing this by cosecant of x. What will I have left in my parentheses? Yep, secant of x minus 1. Okay, now we have two factors. So we have to ask ourselves, what would make the first factor 0 and what would make the second factor 0? Okay, so where would the cosecant of x be equal to 0 at? And where would the secant of x minus 1 be equal to 0? Okay, let's simplify this one step further. What's the secant of x going to be? Just plain old 1. Okay. Now, remembering back to your secant and cosecant, cosecant is the reciprocal of sine. Where did sine start when we were graphing it? At 0. And then it went high, right? And then to the middle, and then low, and then back. So we just kind of quickly sketch this sine wave. Okay? So what did cosecant do? The opposite of that, it became parabolas, right? So we have to put our can't touch this MC hammer asymptotes wherever it's 0, because we cannot divide by 0. And that gives us our guidelines for our parabolas. Okay? And then we say, okay, that's what cosecant is going to do. It's going to follow those guidelines. So is cosecant ever going to be equal to 0? No. So there's not an answer here. Okay? That's not happening. Okay? Now, let's think about secant. What was secant the reciprocal of? The cosine. Where does the cosine start? At 1. It starts high. Okay? Then it went down and ended up high. Okay? So this was cosine. Nice curve. Okay? Then we kind of think about where our poles are going to be. Cannot be the zeros. So at pi over 2, 3 pi over 2, negative pi over 2, and negative 3 pi over 2. Okay, we can't touch those. Now we do our little parabola making. And we ask ourselves, where will the secant be 1? A positive 1. At 0. And where else? 2 pi and negative 2 pi, right? So this is going to be at 0 plus any multiple of 2 pi. Does that make sense to everybody? At 0 and 2 pi and 4 pi and 6 pi, And negative 2 pi, negative 4 pi, negative 6 pi, that's our n. And it's just giving us integers to multiply by 2 pi. Okay? Absolutely. So that's the assignment. I've got it on the board. Okay? This one was the cosecant. Yep. And this was the secant. It will help you to graph them, but it won't be required. Okay? And these are going to show up again on the final, so we want to keep remembering how to graph these things. All right, let me pause my video.